to the mathematics. A sub to the channel will be helpful. Today, our focus is on rationalization of surds. But before we begin, don't forget to like the video and leave a comment. Rationalization of the denominator. We've looked at the first part of the video that was on the introduction to surds, addition, subtraction, and multiplication of surds. Now let's look at rationalization of the denominator. Now, when simplifying fractions containing surds at the denominator, it is usually more convenient to make the denominator rational so as to avoid division by a decimal. The process of making the denominator rational is what is called rationalization. Now let's see a fraction here. That is 1 over root of a. Now, with this fraction, we want to rationalize it so that we make the denominator rational. Then we multiply it by root of a over root of a. Then we get root of a all of root of a squared. Then this square cancels the root sign and we get root a over a. So then let's try a few worked examples. Now 1 over root of 3. Now if you look at the principle here, we know that the answer is root of 3 all over 3. That's the answer we are supposed to get. But what is the process? Now let's move on. The process: 1 over root of 3 multiplied by root 3 all of root of 3. Now don't cancel this. We want to reach a denominator that is rational. Now let's see, we get root of 3 all on root of 3 squared as in this place. Then we cancel the square, use the square to cancel the roots, then we get 3. So this is the process. Let's see a question here. 7 root of 3 multiplying root of 5. So what do we do? 7 root of 3 all on root of 5. We multiply it by root of 5 over root of 5. Then we get what? What do we get? We get 7, 5 multiplying 3, we get 15, then all over what? 5. Let's try one more. So we have 3 plus root of 5 all on root of 7. So 3 plus root of 5 all on root of 7 multiplying what? Root of 7 all on root of 7. Then the root of 7 will multiply everything here. Everything here. So then we get what? We get 3 root of 7. 3 root of 7 plus what? Root of what? 5 multiplying 7 gives 35. We get root of 35 here. Then we get 7 here. Simple as ABC. Now let's see these questions. The denominators were like this: root of 3, root of 5. They were just one root. Now let's see rationalizing surds with binomial denominator, where the denominator is expressed as a plus b, a plus root of b. So now conjugate surds. Given the surd expression a plus b, a plus root of b, then its conjugate is a minus root of b. So then the conjugate of root of 5 plus root of 7 is what? Root of 5 minus root of 7. How do we get this? We just change the sign separating the terms. So if it's addition, we change it to subtraction, and if it is subtraction, we change it to addition to gain its conjugate. Now the product of a surd expression and its conjugate is not a surd. That's why when we are simplifying, when you are rationalizing surds with binomial denominator, we do not multiply it by itself because the answer we get is the surd. But meanwhile, I want to get a rational denominator. So then when we multiply a surd expression and its conjugate, the answer is not a surd, meaning we achieve our primary purpose as we have it to get a denominator that's rational. So now let's see if we have a plus root of b, multiplying its conjugate a minus root of b, we get a squared minus b. So then when rationalizing a fractional surd whose denominator is of the form p root of a plus q root of b or a plus p root of b, it is always important to multiply the numerator and denominator by the conjugate of the denominator. Now let's work. Now this is 1 over root 3 minus 1. So then we multiply it by its conjugate. So 1 over root of 3 minus 1 multiplied by what? Root 3, root of 3 plus 1. Then what? All over what? Root of 3 plus 1. What do we get? Now we get what? This will multiply the 1 here. We get root of 3 plus 1 all over. Then we solve this. Now when we solve this, we get root of 3 multiplying root of 3, which gives 3. Then minus, then this root of 3 multiply this one. Then this minus 1 multiply this minus root of 3. So then the multiplication between this and this cancels the multiplication between this and this. And this is minus 1 multiplying 1, which gives what? Minus 1. So the answer here we get with 2. So then our final answer will be root of 3 plus 1 all over 2. All over 2, simple as ABC. Let's continue. Let's try this. 4 over root of 7 minus root of 3. What do we get? We get 4 multiplying the conjugate of this. That is root of 7 plus root of 3. All over what? And the conjugate of this one too. The conjugates will multiply themselves. So root of 7 minus root of 3 multiplying root of 7 plus root of 3. What do we get? We will get our answer to be 4 root of 7 plus 4 root of 3 all over what? So then we do 7. This will be 7 root of 7 multiplying root of 7, we get 7 minus, then this root 3 minus root of 3, we get minus 3, so we get 4. Our answer here to be 4. You can work out the missing steps. Let's see. Try this last one yourself. 3 root of 5 minus root of 2, 2 root of 5 plus root of 2.